Hey guys, welcome back to another video. My name is Glove and this is Coding with Glove, or if you just pronounce it how it's spelled, Coding with Glove. In this video, we're going to be taking a look at basically what I've done for the past week or so in regards to the StackDB, which is that database project. If you're new to the channel, basically what happened was a couple weeks ago I decided I was going to create my own database. Databases are something that just really always have fascinated me, and I think they're really cool and interesting and technologically interesting as well. So I figured, why not? I'll try and build my own, and it'll be a great learning experience at the very least, and in a best case scenario, it'll be something that I can actually use, and maybe even something that other people can actually use. So in this video, I'm just going to be updating you what I've been doing the past week, and I'm going to also be going into what I'll be doing in the week ahead, or at least what I hope to do in the week ahead. So the first thing that I want to do is go through the updates that I made to the Git repository on GitHub. I think those are kind of starting to look like a real project here, which is kind of exciting. So first things first, I have a nice structure to the actual project following a more standardized Go project structure. I don't remember exactly if I had that or didn't have that last week, but I at least have it this week. Next, in terms of the actual README, I think it's probably a lot more helpful now. It has a little bit more than just a description here. Now it actually has some badges, and you can actually install the application or the database. You can also run the setup process, and then you can also create a new database, which isn't completely done, but the actual creation of the database part is done, and I'll get into that in 1 second. But I think it's also pretty cool because I do also have a CLI now that is a part of this, so that's also pretty cool. I'm using a project or a module called Cobra, which is a very, very popular module for Go to be able to basically build CLI applications. And so I'm using that in here too. Other than that, though, I think that's probably the coolest parts. At least I think the coolest parts are really this README now, because that means that people can actually use it and there's stuff that's worth talking about in this project. But other than that, the next thing I want to talk about is my UML diagram. So essentially, I don't remember, to be honest, I don't really remember like exactly what I talked about in the last video. Having said that, it's still kind of interesting because I did make a really important change from what it originally was. So originally I had in the on disk file structure of a database, there was a file for the database, which was like the database file, and that had some meta information about the database. It had a slice or an array. They're not the same thing, but slices are built on top of arrays. We can make another video about that later. It had a slice of all of the collection names. A collection, if you're familiar with NoSQL, that'll make sense to you. If you're not, a collection is like a table in like a relational database. And then, it had a collections folder, and each collection had its own file, and so I think it was more scalable, but it was harder to kind of deal with, at least for right now, for where the project is at currently. So the change that I made is that basically now a database is stored inside of a single file, and this single file has all of the meta information. It has all of the collections, and inside of the collections it has all of the the data blocks, if you will. A data block or a data type in the code implementation would be like a row if you're using a relational database. So it has all of these data blocks in it, right? So basically the difference is that before we had a bunch of different files for a database to store all the information. Now we have one single file to do that. And the thing that's important here is that the reason that I did it also came with what I think will end up being a pretty impactful trade-off down the road that will kind of limit the scalability, and I'll end up having to change how this works down the road. And that trade-off is that having multiple files within a database to support a single database is harder to deal with, because you basically have to sync up the information that's flowing out of each individual file with the information that's flowing out of a different individual file to be able to work together to have that database work properly, or have any database work properly for that matter. But now what I've done is I've made it all one file, which means that I don't really have to, I still have to sync things, but I don't have to sync things as much in terms of different files. The implication of that is that this one single file is eventually going to get really, really big, and there will ultimately be a potentially, I think, be a problem finding somewhere to put on the actual disk or SSD or on the hard drive or the drive in general, right? So if it's really, really small, which it is to start, it'll be no problem, likely, right? If you have, let's say, if you're using EC2 on AWS, there won't really be a problem here because let's say that you're using, the default, 10 gigs of storage, right? Okay, not an issue. And yeah, you could potentially run out of storage in both cases. The difference is that in the case of having everything stored in one file, you need to find a space on the disk big enough to hold one file that big. Whereas if you're storing things in separate files based on like maybe a file per collection, or even smaller than a single collection, you're breaking the collections into multiple files, then you don't really need, let's say, a single space that's 1 GB in size to store the database. You could store the database in various places across the disk and just access them that way and perhaps load them into memory all at once to make it faster or whatever it is. So I think that will be the implication going down the road, and a pretty significant and maybe even severe trade-off that ends up being that kind of I shot myself in the foot. But the reason that I did this was for the case of just making this work, making it something that's usable and that can, iterate and grow from then on. I thought this would just be a lot easier for me to deal with. And in the future, I'll deal with whatever comes up in the future and have to, suffer the consequences if there are consequences, which I think there will be as they come up. So that's that. So basically, this and this will both be inside of here, right? Because this data struct is inside of this collection struct, and the collection struct lives inside of the database struct. Next, now what can the database do? So the database is able to, you can create a new database, you can insert data into a new database, you can read a database which will just return you the meta information of said database. You can edit it, which will also return you won't be editing data at that point, you'll just be editing meta information about the database. You can load a database, which is actually what would put a database, the entire thing, including all of the data, into memory. And then you can search it, which is basically like find or something like that if you're familiar with MongoDB. So that's what you can do on a database. On a collection, basically CRUD and then some like helper stuff. On a collection, you can create, read, edit, and delete. So basically CRUD on a collection. And then on data, you can only edit or delete. If you're going to search for data, so retrieve data, you would want to do that on the database because chances are you're looking for data, you're searching for data in the entire database. You might not know exactly what you want. Even if you do know exactly what you want, you're still going to be searching the entire database, not a data struct, if that makes sense. So anyway, that's the UML diagram. That's kind of the architecture of, well, not architecture, but that's kind of how, the code is sort of designed. And then there was one other thing that I wanted to talk about. Oh, well, I mentioned this last week, but basically what will happen is that everything will be stored on disk, and then there will be like an active database, and other databases use this too. Like I think MongoDB has like a use function that basically does this exact thing. It allows you to interact with a specific database, and I don't know if you can interact with other databases actually, at least if you're using the shell. So I'm going to have like a similar thing. The kind of like the kicker here is that when you load a database to become the active database, you'll be loading it into memory, which will basically speed up the process of reading, it'll speed up the process of editing, of writing, of all that cool stuff. So that's why I'm going with that approach. And then the thing that I wanted to really touch on that I'm going to be working on this week is my goal is to get inserting into a database working. So after I finish the creation of a new database, so if I do like make clean, just gotta make sure this is clear, make build, don't worry if you can't see this, nothing interesting is happening there. So if we do StackDB, let me zoom in here so you guys There you go. Okay, so if I do StackDB and then what was it? It's database. Actually, let me refresh this. Right, I'll refresh this way. Oh, StackDB. I have to run the setup process, so I probably should remember to do that. We'll get this new file structure here, and inside of data, we have. Well, this actually still sets up the file structure as it was the old way, so that's part of what I was talking about that I'm not done yet. But the cool thing is that inside of here we do have collections, and then this has a collection called database, so now everything is being stored inside of the database.json file. But we do have to update the actual files that are being created, right? And so now if I were to do, and you'll see the same thing. Actually, no, do I have to show you that? No, because I think this actually just illustrates my point, which is that we aren't going to want this here. We'll actually, you know what? We don't even want this folder here. Really what we just want is database or system.json, and that would be the entire database. Okay, that actually got a lot easier. But basically what's going to be happening is that inside of this system database, we're going to have a collection right here, as you can see. Maybe that makes it a little bit easier. Collections called database, or databases in plural, and then basically this is going to store all of the databases, or all of the information about the databases that are inside of your implementation, or your I guess implementation or service, or local instance of instance of StackDB. And so a lot of databases actually do this, where they maintain a state of everything going on in the system, and so this is pretty much what we're trying to do here. So that is pretty much it. In the coming week, I'm going to be working on actually being able to write to a database, so that you'll actually be able to do just that, right? Write data, whatever that data is, doesn't really matter. Write data to the database, and so that's what I'll be working on. So I hope this wasn't too boring. Hopefully next week I'll be able to actually have something to demonstrate, like, hey, this is how you actually use StackDB. I think that'd be pretty cool. But thank you guys so much for watching. If you enjoyed this video and want to follow this journey, I'm going to try and make these videos a little bit more lively and interesting. But please definitely let me know down in the comments, like, how can I make these videos more interesting? I would love to know that, because I feel like it's just me rambling. But either way, thanks again for watching. If you enjoyed, definitely subscribe, rate, comment, all that stuff. And I'll see you guys in the next video. Take care.